Hello, my name is Andrew Skank, and today I'm going to be talking to you about my science fair project. This year, I did my science fair project on the effect that plastic leaching would have on grass growth. I chose this as a continuation off of last year's project, where I looked at simply will plastic pollution affect grass growth? This year, I wanted to take it a step forward, and I wanted to look at why this would happen, and specifically, I wanted to look at if plastic would start leaching, breaking down in the natural degradation process. So what I did was I first exposed pieces of plastic into a UV chamber. I put it in there for 500 hours, which simulates about 5 years of natural weathering. I did this to start the natural degradation process that plastics have because I wanted to start getting it breaking down so it would start to potentially leach hazardous chemicals. Then I shredded the plastics using a shredder to produce small microplastics. Specifically, I had 3 different plastics: high density polyethylene, polypropylene, and polyethylene terephthalate. My hypothesis of this experiment was that out of my 3 plastics, polyethylene terephthalate would start breaking down and leaching chemicals into my soil. However, the other 2 plastics, polypropylene and high density polyethylene, would not. So, to do my testing, after I had my plastics shredded and exposed, I put them into the soil where I grew grass. I put 5 grams of plastic into each cup of my plants. I had 15 different cups of each plastic and also 15 as a control, so I had a total of 60 plants growing. I let these plants grow for 10 days total. I watered them twice a day. They had adequate sunlight. They were all in the same area, so all that was kept controlled as possible. And then, after the 10 days, I used deionized water to extract it. I mixed it around and I got it so it was basically all liquidy. This liquid allowed me to do a vacuum filter. The vacuum filter does a similar process to what regular filtration does. However, it does it at a much faster pace. So this allowed me to get 60 yellowish, dirty liquids that I could then do my testing. For my actual testing, I used an infrared spectrometer. This infrared spectrometer looks at how different particles react when they are exposed to light. So this helps you know if there is something in there, such as plastic. So what I did first was I tested plain pieces of each plastic. And also a plain piece of dirt. These produce baseline spectrum that I can use to later compare to my results. The results of these first testings are in that figure. I know it might be hard to see, but it's also in my research plan. These testings produced figure line spectrums, specifically, that were very extreme, lots of dips, very distinct. So this would allow me to see actual testing if I have plastic in my soil. So then what I did was I used my solution. It was pretty liquidy, and then I tested it with the infrared spectrometer, and it produced a line, as you can see here in figure 2. These spectrum right there, they were not very intense, and they had lots of lines that did not look like the actual spectrum of what the plastic. So this allowed me to conclude that there was no plastic whatsoever in that. But then I wanted to make sure, so I used an oven to condense the solution more so it was more concentrated. And then I tested it again, and it produced very, very similar lines that were not an intense spectrum. They didn't really find anything. So finally, I used an oven one more time to get an even more intense spectrum. These produced a very intense spectrum, but it was not remotely similar to any of the plastics. In fact, it was very similar to dirt. So this allows me to conclude that there was no plastic leaching into the soil whatsoever, but I did find dirt. Here, I'll show you my graphs right here. So in this top one is what the plastics look like by themselves. Then this one over here is the full liquid solution. This one's the half concentrated. And then this one here is when the oven was used, so it was completely dry. So with these spectrums, I can conclude that there was no plastic found in there whatsoever. I didn't get any results that looked like there could be any plastic. So in the future, I'd like to actually be able to find some more plastic. So I want to try and use the UV chamber for a lot longer period of time. The amount of time I used it simulated about 5 years, which is not enough to get the really complex process of the plastic degradation started. I thought that maybe it might be able to get something for polyethylene terephthalate because that one's very known to break down easily, and especially when just even around heat. So I thought that after 5 years I might be able to get something going, but unfortunately I wasn't able to. So in the future, a lot longer period of time in the UV chamber might be able to give me better results that are more accurate to long-term plastic pollution. In the future, I'd also like to correct certain things, such as using a UV light specifically for my grass growing instead of just an ordinary sunlight by a window. This would give me more precise results, and it would be a lot more like realistic to natural outside in the soil, really growing, like how you would see with plastic pollution. So in this experiment, I learned a lot about how plastic still does hinder the growth of grass. So that tells me that in general, pollution is still very bad, and as a society, it's something we need to work on. However, I wasn't able to determine any results of the plastic leaching into the grass after a 5 year period of simulated time. So that was my science fair project. Thank you for your time. I hope you enjoy.